So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 6 of the May Daily Leetcode challenge and we have a medium level question in front of us. Let us see what the question is, okay? It's question 1498. Number of subsequences that satisfy the given sum condition, okay? So one thing that I can say is that you should be knowing what are subsequences. If you are doubting subsequences to be equal to subarrays, then let me tell you they are different. So like please do this as a homework. Please go and look out for what are subsequences. Let me tell you they are totally different from subarrays. Okay. So let me give you a good example. See, for example, 3 5 6 is a subarray. Subarray means all the elements are like together. Okay, 3 5 6 are together, but 3 5 and 7. This is a subsequence. Okay, in a subsequence, the elements need not be together in the array. Okay, but 3 5 and 7 is not a subarray. Subarray means it should be a portion of the given array. Okay, so for example, 5 6 7. Okay, but we can say that 3 5 and 7 is a subsequence. The only criteria is that the elements of subsequence should be present in the array. They need not be together in the array. Okay, their positions need not be connected. That is a basic difference. You can also search for it in Google or Wikipedia. You will get some nice examples, right? Now coming to today's question. See, we are given two things here. We are given numbers, nums array, and we are given a target. Okay, what they're saying is return the number of non-empty subsequences of nums such that the sum of the minimum and the maximum element on it is less than or equal to target. Okay. And finally, we return the answer. See, because the answer is going to be large, we have to do this modulo and return the answer. Okay. I will again repeat. Return the number of non-empty subsequences of nums such that the sum of the minimum and the maximum element on it is less than or equal to target. One thing is very, very clear. We are bothered only about the minimum and the maximum element. And one more hint they are giving is that it's a subsequence. Okay. It need not be a continuous one. Okay. So what we can do is before going to the approach, let me tell you how to do this like in a brute force way. Okay. See, again and again, just bring your mind this way. Okay. We have to think only about the minimum and the maximum. Rest all numbers do not matter here. Okay. What are the other numbers? We do not matter. Okay. So first of all, let us understand how to do it in a brute force approach. Brute force approach, what I will do is I will try to find all possible sequences. Okay. I will try to find all possible sequences. Okay, that will have some time complexity. Then I will go through each of those sequences in a linear way and try to find the minimum and the maximum element. Then I will check if it is less than the sum is less than or equal to target. So how much time complexity it will take? Let us understand that. Okay. See, this is all about maths, but let me tell you this because these things are important in interviews. See, for example, let me talk about this element. There are two ways for it. Okay, either it is present or it is absent. So two ways. Okay, same for this. Either it is present or it is absent. Okay, same for this and same for this. Okay, so what we are doing is we will multiply all these twos together. Okay, see, for this there are two ways, for this there are two, either it is present or an absent, right? These are the only possibilities for it. Okay, so two we are multiplying with, see, how many twos are present, and twos, because see, this and this n, right? So we have, for each of them there are possibilities two, so it will be 2 into 2 into 2 into 2 like this for n times. So what it is 2 power n. Okay, so total number of possible subsequences of an array of size n is 2 power n. Okay, size is 2 power n. Now we have just the subsequence. Okay, we have to go through it to find the minimum and maximum. That will take O of n time complexity. So the total time complexity, if we are following the brute force approach, is going to be 2 power n into n. Okay, this is going to very, very big. See, the time complexity you see here means the constraints you see here. These are very big constraints. Okay, we cannot afford to have a solution of this much time complexity. So this approach is not possible. Now let's come to the optimized approach. See, we need only the minimum. See, because see this, if this thing is not present, then maybe such a see, if it is a sub array, then maybe we cannot go below n log n or n square approach. Okay, but in this question we are given subsequence. Let us say the advantage of it. Okay, we can traverse all possible minimum maximum combinations and check if they are valid. Okay, see, I am bothered only about minimum and maximum. Okay, I am not at all bothered about other elements. So what my idea is, just see the theory here, then we'll go to the example that will very make it very clear for you. Okay, so I'm going to bother only about the minimum and maximum combinations which are valid. Okay, valid means which sum is less than or equal to the target. Okay, see, sum is sum and minimum and maximum is less. See, they are less than and equal to. Do not forget these things. Less than and equal to. Okay. Then we can freely pick elements within the range. This. So let me quickly go to the example, then I will come back to this. Okay. So yeah, this is the example. See here. See, the given target is 18. Okay. So suppose I am at see left. I am going to start from 3. Then left will keep on increasing. Okay, do not think about left currently. See, just imagine left is 5 by default. Okay, how to find the right? Right means see. First of all, my nums array is given to me. I have sorted it. Okay, you can clearly see this nums array is sorted. Right. First, I will fix a left. See, currently right is not fixed. Only left is fixed. Left is fixed at 5. Okay. Now, what should be my right? Okay. What I will, how to do that? See, we know the target is 18. I know that the left element plus the right element should be less than or equal to 18. What I will do is I will subtract target from my left element. I will do 18 minus 5, which is 13. Okay. So my right can go up to element less than or equal to 13. We can clearly see 13 is not present here. So the element which is rightmost, see, please understand each word carefully. The element which is rightmost and less than 13 is 12. Okay. So what we did, we sorted the array first. We fixed the left. See, what the logic behind fixing left at 5? We do not go for that. Okay, that is we'll come to it later. But just think that left is fixed. We are trying to find right. So in this example, I'm only going to teach you how to find right. Okay, we are subtracting target. We are subtracting left element from target, which we are getting 13. We need to find the rightmost element in the array. Rightmost means the index with the see the number which is the for which the index is the highest. Okay, rightmost element which is less than or equal to 13, we get 12. Okay, we can clearly see 12 plus 5 which is 17. Okay, so now suppose we know that this combination of min and max is valid. Okay, because 5 plus 12 is less than 18. Now how to now we'll fix left that see that now we are going to find all possible subsequences with minimum as 5 and maximum as 12. How to do that? See, we can clearly see what are the elements which are lying in between them. See, 6, 6, 9, 10. These are the elements. This see in the real life, this may not be in between 5 and 12, but as I told you, we are given we are need to find only subsequences. We do not need to find sub-arrays, right? So even if they are not present between 5 and 12, we can consider them. Okay, how to find them? Okay, see, as I told in the starting, see the possibility of 6 being present in the subsequence is 2. Okay, why? Either it is present or it is absent. So okay, so 2 ways. Similarly for this 6, 2 ways. Therefore this 9, 2 ways. For this 10, 2 ways. Okay, even for these 12 ways, because see, suppose I am selecting only 5. Okay, I am selecting only 5. So minimum is also 5, maximum is also 5. 5 plus 5 is 10, definitely is less than target. So even 5 is a valid subsequence. Okay, individually. So for this 6 two ways, for this 6 two ways, for this 9 two ways, for this 10 two ways, for this 12 two ways, what are 2 ways? Either is present or absent. Okay, that's what 2 ways. So 2 into 2 into 2 into 2 into 2. So total, so 2 power 5. Okay, the 2 we are multiplying with itself by 5 times, so it is 2 power 5, 32 ways. So there are 32 ways uh, in which we can get a valid subsequence whose minimum is 5. Okay, 2 power 5, and if we do not consider 12, that means there are 2 power 4 such subsequences whose minimum is 5 and whose maximum is 12. That is the way we are going to do. Okay, so we are going to find first of all the valid combinations of left, which is minimum and the maximum. If the combination is valid, that means its sum is less than 18. We are then going to see how many subsequences are possible. How to find that? Just subtract c index of 12 minus index of 5. Okay, we'll get some answer. Just raise it to the power of 2. For example, in this case, see, if you subtract the index of 12 and the index of 5, you are going to get 5. Okay, see, 1 2 3 4, subtract index of 12 minus index of 5, you are going to get 5. Okay, 2 or 5 is 32. That means there are 32 subsequences whose minimum is 5. Okay, and they're valid also. That is the basic idea behind this, and that we are going to code. I hope my like what I explained is like you can always reverse the video and see. Okay, that is the only thing I can say. See, these examples I have like prepared it for you. I'm like each word here has a meaning. Okay, if you're missing even a single word, maybe you will not able to understand. That's why my advice to you will be, please pause the video and please make like you can reduce the speed of the video as well, right? So now you will be able to answer the meaning of the statement. See, first we will fix all. See, we'll go through all possible combinations of minimum and maximum, as I told you, and then if we check if they're valid, valid means the sum should be less than the target. Okay. Once we fix the minimum and maximum, what we can do is then we can freely pick elements within the range. Left refers to the minimum, right refers to the maximum which we have fixed to make valid subsequences. Again, I will say, then we can freely pick the elements within the range left plus one right to make the valid subsequences. Okay. Let us go for the code now. I think I have not explained you the examples. Okay, let us quickly see them as well. See, this is the subsequence given. So this is the array given to us, and the target is 9. Okay. So which are the ones? See, they have listed here. See, 3. Why it is possible? See, minimum is also 3, maximum also 3. Okay. 3 plus 3 is 6. So it's less than 9. That's why this is possible. Here maximum is 5, minimum is 3. 3 plus 5 is less than 9. 3 and 6 are less than 9. Again, 3 and 6 are less than 9. Okay. So see, once you fix 3 and 6, we either 5 is present or not present. Okay. See, these are the two cases in which either 5 is present or not present. In the first case, 5 is present, and the next case is not present. See, that's how we are doing it. Okay. And here also, see, these examples are self-explanatory. That's why I'm not like focusing much on them. You can just go through it in your free time. There are 6 sequences. See, they have just listed out 6 sequences. Okay. It's already sorted here in this case, and same is the case of this. Okay. You can just go through them. See, they are not much self-explanatory. That's why we are coming to the code end. Okay. See, and I am just taking the length of the nums. Mod as see, we have written finally the answer. This thing. Okay. That's why I've taken mod as 10 power 9 plus 7. In Python, this thing is 10 power 9. Okay. 10 raised to the power 9. We can, if we do 10 star star 9, that means it's 10 raised to the power 9. Okay. Finally, we are starting nums in its own like container. This is going to be the final answer which we are going to return. Okay. See, this is how we are fixing left. Okay, what we are doing is left will be starting from 0 and it will be going till n minus 1. Okay. See, in the example as I clearly told you, I remember that left. See, do not bother about left. We have to find only the right. Okay, as in the example I told you. And see, this is how we are fixing left. Okay, left will be from 0 to n minus 1. For each left, we will find the right. Okay. See, before going further, see, this is the first time I'm going to use this bisect function. So let me quickly give you the syntax for it. Okay. See, bisect function is to find. Okay, first of all, let me tell you, stamp complexity. It works like a linear binary search way. Okay, it works only on sorted containers, and it actually it works like a binary search works. Okay, so stamp complexity is exactly similar to that of binary search. Let me tell you how it works. Okay, see, this is for example bisect dot write. What it means is, see, we are going to give the sorted list here. See, these are the syntax for it. Okay, we are going to give first index is sorted list. Then we have to find the number which we are going to insert. Then the beginning, so from like where we start inserting it. See, for example, see here, this is 3368. Okay, this is sorted. Suppose I want to insert 7 into it. Okay, how to insert 7? I have to insert 7 in such a way that it remains sorted. This is what is done by bisect. Okay, bisect right means, suppose there are two elements. See, for example, I want to insert 3. I should insert 3 after, to the rightmost possible. Okay, see, through the rightmost index possible. Bisect right means it will insert to the rightmost index possible. For example, if I want to insert 3 in this again, there are 2 3s already, so the next 3 will be inserted in the index 2. Okay, to 0 and 1 already 3, now 2 also will be that. Okay, that is what is meant by bisect right. Okay, this is the sorted list. This is the number which we want to insert, and this is the beginning and end index we want to consider. If you do not pass them, that means by default the beginning is 0 and the end is n minus 1. That is the basic idea. What it will return is, it will return the possible index in which we can insert that element. Okay, that is the basic idea. That is what we are going to use here. But you will be thinking why we need binary search. Okay, see, the idea here is, suppose I fix 5. Okay, I'm now aware what is the constraints for my right. Okay, it should be less than or equal to target minus left element. Okay, 18 minus 5, which is 13. Okay, it should be less than or equal to 13. See, we can see the left, see, all the right elements of the left are sorted. Okay, 6 6 9 10 12 14 are sorted. I am going to do a binary search here to get the element which is the rightmost and less than or equal to target. Sorry, less than or equal to the key, which is target minus leftmost element. Okay, I will repeat, let me call it as a key. Target minus leftmost element, I am calling it as a key. Okay, I am going to do binary search to find the rightmost element which is less than or equal to key. Okay, from the index right to the, see, this is left. So from the next most index we are going to start till the last index. Okay, that is the basic idea. That is what we are doing here. See, first I will find key. Key is going to be the target minus nums of left. Okay, my right most element, sorry, for the right element should be less than or equal to the key. Okay. One thing here, see, if my nums itself is, this is going to be the rightmost element, if this itself is going to be bigger than target, there is no meaning of finding the rightmost element. That's why I'm taking. See, if this difference is less than 0, then break the loop, because see, this is a sorted. See, we are sorting it, right? If I is current, see, for the example, for the current left, if it is like it's greater than the target, then obviously the elements which left will always be greater than the target. That's why we are breaking the array here. Okay, if this difference is less than 0, we are breaking the target here. This is optimization. It's not given in the official solution also, but this is optimization which I've added. Okay, now we are going to do basic. See what it means is, we are, see, suppose I'm inserting key into the num set. Okay, it will then give me the possible index for key. Okay, but we know that any, see, suppose this returns a, let's say the number I. Okay, I know that I minus 1 is definitely a number less than or equal to key. That's what we're using here. This bisect function, we are passing the key as the second argument, and we are doing a minus 1 here. Okay, see, this will return me the index which is, okay, suitable for inserting key. Okay, such that the nums array remains sorted. But I need to find the rightmost element which is less than key. Okay, so what I will do, I will just minus 1 from whatever is written from this function. Okay, I will just do a minus 1 here. Okay, that is the basic idea. That is going to be my right. I will again check, okay, if my right is still greater than equal to left. Okay, if it is not greater than equal to left, then we can't do anything. Okay, then as I told you, we will find the subsequences. We now right and left are fixed. Okay, at this point right and left are fixed. Okay, at this point right and left are fixed. Now we are going to find the number of subsequences. As I told you how to find that, 2 raised to the power right minus left. Okay, 2 raised to the power right minus left. Okay, this will give you the number of subsequences possible. Okay, how we are getting, as I told you, for each element there is a possibility either it is included or not included. So there are two ways. And similarly, for how many elements we are doing like this, for right minus left elements. Okay, so 2 into like this for right minus left number of times. So it is 2 raised to power right minus left. And for each we are doing mod. Okay. Finally, we are returning answer. We are again doing mod. For each thing, it will be added to our answer, and finally we are returning the mod. So the basic idea here is, we are fixing right and left first. Okay, and then we are doing, see, first left is fixed, then we are doing a binary search to find right, and once they are found, we are just doing a math calculation to get the array. So how to find the time complexity? See, for finding the left, it is going to be, let me write here, yeah, the time complexity. See, for finding left, it is going to be 4 often, because we are doing a simple array, right? We're going to simple, like for all elements we are swapping once, right? And for finding right, we are going to use the binary search approach. Okay, this is the binary search approach for finding right. It is going to take log n times. Okay, so this is for right. So together for each left we are doing this. So yeah, so total time count is going to be n log n times. Okay. See, uh, we are again, see, sort is also involved. So again, that you can say like this also contributes n log n times. So if you see the overall time complexity is going to be n log n. And space complexity wise, we are, see, if you space complexity wise, actually it is O of 1, but technically speaking, because we are using sort will also require some extra containers. If you consider that, then also it's going to be n log n. But if you are in an interview, if you are asked to explain the time space complexity, then you can first say O of 1, and if they ask to consider the space required for sorting, then you can say, yeah, it's going to be n log n. Okay, that is the basic idea, and yeah, friend, that was all. So the basic idea is, first fix left and right. Once it is fixed, we can see, because it's subsequence, so it makes our work easy. We can just do a maths calculation here to find the number of subsequences. Okay, that is, the elements which are between left and right, with that is the elements which are between left minimum and maximum. We're just going to consider them either they're included or they're excluded. Okay, so that can be found in 2 raised to power right minus left ways. Okay, that is, see, it's all maths. Okay, while explaining this example, I have given you a detailed explanation of how this formula is coming. See, for example, 6. Suppose 5 and 10, 12 are fixed. So 6, either it can be included or not included. So 2 ways. This also 2 ways. This also 2 ways. So we are going to multiply 2 with itself for these many number of times. Okay, that's why we are doing 2 raised to power right minus left. Okay? That was the idea. So, yeah, friends, that was all. And I will explain you the time complexity also. If you have any doubts, please do comment below. And if you have any further optimizations like this, then please mention that as well. Thanks a lot. Yeah, that's all for today.